Yeah. So just turn off the fan a second. Okay, so turn off the fan just to make sure that my voice is clear enough. Let's start. Good morning. Today the date is 20th of August 2020. It is Saturday and the time is 10:58. It's almost 11. It's almost 11. We got little late today at 9:30. Anyways, uh, there's one problem I have been thinking about for quite some time, and that is like the problem which this problem I didn't look this problem in some literature on the internet, but rather I found this problem by by my own. It's not a very big problem. It's not like some complex thing, but it's very simple. But I haven't thought about it yet. So let's start. Let me explain the problem. I was walking on a road in the campus only, and I there was a corner turn, 90-degree turn. So I was walking, and I had to cross that. I had to went through that corner in order to reach my destination or like go further. But there was another option for me to. Then there was another path for me to take, which was not. Uh, Let me just explain this on the paper. Yeah. So actually, in my campus, what kindly ignore this all this stuff. This is of my materials engineering class. Right. Okay. Let's focus below this line. Okay. So the corner was like this. The path was like this. Like this was the road, and I was here. Let's pretend this is me, and I had to go in this direction, like here. This was one of the my option to take the path, but I had on another option. Although this was not road, but there was a path like this also. Here was the some kind of parking lot, and uh, here was some building, and this was a parking lot. But there was some path like this. So I thought, what would be shorter for me to go from point this, let's say call it point A, and let's call this point B. What path would be shorter for me to go from point A to point B? Then I thought, like this distance, let's say this distance is x, and for simplicity, let's also pretend this distance is also x. Okay, these both two of the distance are x, and and this path would also be x because it's as long as it is parallel to this, it would also be x, and this path would also be x. Okay, so there's a simple conclusion here that no matter what path I choose, it will take equal amount of time for me. Okay, that's fair enough. It's not really confusing. It's as simple as it can be. But now the thing is, what if uh, uh okay, let's spin this on the coordinate system. Let's make a coordinate system y, and this is x-axis, and this is the same situation. If I am at the point A, I have to go at the point B. This is one available path which I have drawn here, and for simplicity, let's take these lengths to be equal, which is equals to x. Now the other option I had, like in this particular case, like this one, was to go from here and then turn or take a turn to go there. In this case, it would also be x. This would also be x. So it won't make a difference. Now let us uh, do another thing, that is, rather than, okay, just a second. Kindly wait a second. I'm thinking of the problem. Just a second. Just a minute. So I'll pause for a second and then I'll be back. Okay. I hope I'm back. Is it recording? Yeah, I think it's recording. Okay, right. Oh, I'm sorry. It took me a while to uh, to recall the problem. Now, yeah, here we are. In this case, rather than taking this particular original distance, original path, I took this path, and all, and I we can easily conclude here that taking this path doesn't actually decreases my time or the distance for me to go from point A to point B. Now let us do another thing. Let's say, sorry, let's say this is point A, this is point B, here's point A, and this was my original path. Rather than doing this, what can I let's take another path that might not be applicable to this original area, but let's assume that it's a clean plane area and you can take any path to go from point A to point B. Let's take this path, like the kind of this, such that this length is x, or this is x, this is x, this is x by 2, this is also x by 2, this is x by 2, this is x by 2. Basically what we did here is, rather than going from this was the original path, in this case we took this particular path. Rather than going from this to this, what we did, we went half the way, then we turned right. We went half, again x by 2, we turned left, or the in the y direction, and then we went to the point B by going along the x-axis. So this is what we actually did here. Okay, this is x by 2, x by 2, x by 2, x by 2. This all is now. Let us analyze, does taking this kind of path reduces our time? Let's see. Okay, let's count the total distance. It says x by 2, here is x by 2, this is x by 2 again, plus x by 2, here is x by 2 again, and once more it's a x by 2. If you add up all this, you find that it is 2x, which is the original path was also 2x. So the original now is equals to 2x, and here in this particular case, the what, taking this particular path, it was again 2x, and in this case also it's also 2x, same as original. So in this case, reduce like changing the path this way did not affected our total distance. It is same as the original. Let's take this particular situation is equal to n equals to 1, and where n is the um probably the number of individual, sorry, n equals to 2, probably the number of individual paths or individual turns. Like originally the path was to go from point A like this and then take one turn, go to the point B. But in this case where of n equals 2, what we did, rather than going straight, we took a left turn and go in this direction, and took another right turn to go to the point B. So we actually took two turns. One turn at the point A, because originally we had to go in x direction, but rather we turned to y direction, that was turn A, and here we took another turn which is clearly visible. So that's why let's say n2, or we can also say that this was a one individual path, this was the other individual path. So there were two individual paths. In this case, uh, as you can probably guess, n is equal to 4, because if you count it turn-wise, like originally we had to go in this direction, but rather we turned left and went this direction. That's a turn 1. Here we took turn 2, turn 3, and turn 4, and then we reached our destination. Or you can take individual paths, like this was in one individual path, this was the second, this was the third, and this was the fourth. That's why n equals to 4. So at n equals to 2, our in this particular path, uh, we took 2x distance in n equals to 4 was also 2x, which both are same as original. Now let's increase the n. Let's Here we double the n from 2 to 4. Now let's double it again, where n equals to 8. Now let us draw the paths again. This is point A, this is point B, this is the our original path we originally were taking. Now let us draw the n equals to 4. This is dotted path is of n equals to 4. Now let us draw the n equals to 8 path. This particular one, like we will go from here and take a turn, then go there, and this like this. Here we go. So here, this path is of n equals to 8, where there are 8 individual turns or 8 individual paths: 1, 2, 3, 4, 5, 6, 7, and 8. Now let's calculate origin. This particular one was equal to this. It was x by 2, and this is x by 4. Like we divided x by 2 even in two halves, so this comes out to be x by 4, and this all comes to, if you see, this all will be equals to x by 4. Like I'm not going to write it all. So there would be 8 total paths, each of x by 4. Let us calculate the total distance. There is each path is x by 4, total number of path is 8. Let's multiply them together, and we can see again we have 2x as a total distance, which is equals to the original distance. So okay, this isn't any thing new to us. We can see obviously uh, even though we are increasing an number, and the distance isn't reducing. So till here it's not a big thing, it is simple, and we can see the our distance doesn't reduces. But now let us do something where the limits, that is increasing the n to infinity, not to 2, not to 4, not to 8, not to 16, not to 32, not to 64, not to 128, not to any large number, but let's take it to infinity. And let's see that. Now if we take n equals to infinity, that is we are taking infinite number of steps, like very 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 small steps like this, to go from point A to point B. Here is point A, here is point B. Again, if we take a very small step that is not equal to infinity, if we take a very small step, that would be a finite number of the value of n would be a finite number. But if we take infinity, as you can intuitively see, that if we take n equals to infinity, this path would become a straight line. Yes, you're right, it would become a straight line at n equals to infinity. Now let us calculate this distance of line from point A to point B. Here is x, here is x. This was 90 taken originally, and as you can use Pythagoras theorem, that is hypotenuse square equals to base square plus perpendicular square. And here AB is our hypotenuse, length of AB, so its square would be equals to base, which is x square, plus perpendicular, which is also equals to x, equals to 2x square. And if we take the distance of AB equals to square root of 2x square, which comes out to be root 2x here. Okay, So the original distance from point to A to point B was 2x, and at n equals to infinity the distance is root 2x, and they are not same. Wow, now that is a problem, which I was talking about. As you can see, it is the value of root 2 is approximately 1.4. Let me just check the exact value of the root 2. Here we will go. Just a second. Let's take root 2 is 1.414. That might be would be sufficient for us. Originally it was 2x, now it is 1.414x, which is definitely smaller than the 2x. So as long as in the n equals 2 distance wasn't reduced, in n equals to 4 distance isn't reduced, at n equals to 8 again distance wasn't reduced, it was the same as 2x. So as we can see, if we take a finite number, or uh, at least relatively small number like 8, or even in the order of hundreds or thousand, or even in the orders of lakh, if we see the pattern, it won't change, it will always be 2x. But as soon as we take the n equals to infinity, now it's the distance is reduced. That is insane. So my problem, I have described my problem here. Now it's our uh, it is up to us to solve this problem and find out the solution, or at least an explanation, uh, solution and explanation that why this is happening. Okay, so let's start with the solution. For the solution I have came with, I hope it's a much better setup, like this top down view, and this camera quality and the sound or audio quality. I hope it's much better than previous the question discussion. And let's for briefly go over the question, like what we talked about in the previous part of this video. So the problem is that the problem we were discussing is this triangle, not a triangle, but this is the original path was of distance x plus x. X is this distance and this is also x, and we are proposed shorter distance, so-called shorter distance is like this. And for this part, like one of the option is like go this, where which we call n equals 2 the, and if we put n equals to 4, it is like this. We go x by 2 distance this, and we turn right, again travel x by 2 distance, we turn left, travel x by 2 distance, and again turn right and travel x by 2 distance. Okay, so this was for n equals to 4, and similarly for n equals to 8 it was something like this, and so on and so on. What we proposed previously, if we put n equals to infinity, this path will tend to become a straight line like this, and the distance will reduce, as clearly in the initial, the original path which was x plus x distance, and clearly here the distance is reduced and definitely not equals to x plus x, but rather we calculated it using the Pythagoras theorem, and it turned out to be root 2x. So it was earlier 2x, and then with our proposed this limit of n tending to infinity, the distance was reduced to root 2x, which is definitely a shorter route. But the paradox here is, which we discussed earlier, the paradox here is that okay, so let me explain the paradox once again. Let's keep it aside and start from here. Okay, I'll redraw the diagram, just wait for a second. It's something like this. Okay, and it's like this. Let me just draw a dotted line here. This dotted line was n equals to 2,
but let's draw for n equals to 8, which is this proper solid line. Okay, n equals to 8, this is the thing, this is the distance x, this is x by 4, it would turn out to be x by 4, this would also be x by 4, and so on, so on. Each step would be equals to x by 4. So this particular distance x by 4 is for the case n equals to 8. Let's generalize this length. Let's call this length equals to L, and this L would be equals to, for the general case of n, this L would be equals to x upon n by 2. I hope you can see how it comes, because for the n equals to 4, like this, it would be x by 2. This L would be x by 2 for the n equals to 4, not for the n equals to 8, but for the 4, n equals to 4, this distance would be x by 2. And if we put n equals to 4, 4 divided by 2 is equals to 2, and thus x by 2. And you can clearly see that this thing is half of the x by 2. For n equals to 8, let's put 8 here, and we will get x by 4, and it is x by 4 distance, because if it's x by 4, we will add up this x by 4 plus x by 4 plus x by 4 plus x by 4, that is x by 4 into 1, 2, 3, 4 times turns out to be x, and that is true. Okay, so thus this L distance is equal to x upon n by 2. Now let us see the okay, so let's calculate this distance, this total distance from point A to point B, our proposed distance. This was the original, which is 2x, and this is the proposed distance, and it is let's calculate it, cause here n equals to 8, that is there are total 8 number of steps, and we know also that each step is of length L, then our total distance would be equals to L times 8. Let's put the value of L into the equation, n by 2 will be here, sorry, it's 8, and if we solve it, we can find that it's 16x by n. For n equals to 8, for n, for if you put n equals to 8, it would turn out to be 2x. This distance we specially calculated for n equals to 8 condition, because we put it into here. But if we find the distance for the general case, which is n can be anything, let's find the distance, we call it dg for the general case. The distance would be length, which is this length of the each step multiplied by the total number of steps we have, and for different value of n, we will have different number of steps. Now let us put the equation value of L into the equation, which is, we know, x upon n by 2 into n is also here, and we rearrange this, 2 will go up, it will turn out to be 2x upon n into n. And let us see one thing, that this n can be cancelled out, obviously, because n divided by n is 1. So as we can see, the general equation, even in the general equation, there is no variable such as n. The n has been cancelled out, so there is no role of n in the distance of this whole path from point A to point B. Even if we don't want to do this, like we don't want to cancel out n, let us not cancel out n and rather keep it there, and we will tend the n to the infinity. We put limit n tending to infinity of this dg function, like this particular thing, it would be turn out to be 2x upon infinity into infinity. This limit turns out to be of infinity by infinity form, and we can and although there is no point in doing like this, because this n already gets cancelled out. So there, what I'm trying to say is that there is no role of n in the equation. So it is like a paradox, no? Because what we initially thought that if we reduce this number of steps, as we thought, if we reduce this number of steps, this distance from point A to point V would reduce to a straight line going from point A to point B, which is equals to root 2x, as we calculated from the Pythagoras theorem. But it turns out from the equation that there is no role of n, and thus the total distance of point A to point B is always 2x, no matter how many steps we create in between. So as of now we have already established the paradox. Now we will move on towards the explanation of the paradox. Like, what is the explanation? What is the point we are not able to catch, or what is the point we are missing in our understanding? In order to understand this thing, like this paradox, let us I'm not sure if this is a paradox or it is a paradox is a right term to call it, but anyways, I'm calling it that. Okay, let us break down and see in this case where n equals to infinity. And if we zoom in, let's observe this particular portion, and we zoom into this portion. In this portion there would be very small number of steps like this. It would be thousands or millions or billion, or the infinite. In fact, it would be infinite number of steps, like, but very small. So the main point here is, no matter how many steps we create, even if we create infinite steps, even if we approach infinity, no matter what the value of n is, the steps will always be like these paths will always be parallel to this side or this side. It will always be parallel to the AO or the OB. Like this horizontal path would be parallel to AO, and the vertical path would be parallel to OB. This is the main point we need to understand. Even at the infinity, n equals to infinity, the paths would be always parallel to the AO or AB. So the thing is, even at infinity, because of our constraints, these paths are parallel to either side of the triangle, and not at n. Let's for the case n equals to infinity, let's define the distance of this path h, where h tends to 0. It's where it is not exactly 0, because it cannot be. If it's 0, then we are moving nowhere, but h tends towards 0. Even at that case, if h is very small number, still the distance from the, I'm talking about just one step from I have zoomed into this portion, like, and I have picked up only one step. Even at that small scale, even no matter how small is h, there would be definitely there would be a path which won't have its constraint of being parallel to either side of triangle, and will be a diagonal path. And this path, let us call it h dash, and h dash will definitely be smaller than h. And how much smaller? It would be root h dash would be equals to root 2 times of h. Okay, so this condition holds true for any value of n. This is the main point, that there even if we approach n equals to infinity, the steps are still parallel to the either side of triangle and not diagonal. So this is the important thing we have to understand. Like, if you understand this, then it's pretty much solved. And so basically the problem here is, we defined our problem in a wrong way. If you remember how we defined our statement, what we defined is that if you divide this distance into n number of steps like this from A to B, then the as you increase the number of steps, as you increase n towards infinity, it would tend to become the diagonal of the triangle like a hypotenuse. This particular statement itself is wrong. It will not tend to become the hypotenuse of the triangle, because hypotenuse of the triangle is a line which is diagonal, which is not parallel to AO or AB. It is not parallel to either side of triangle. It is diagonal to the sides of the triangle. But in our case, in this case, it is, we have already put a constraint that this angle is 90 degree. So no matter how what is n, it is always parallel to the either side of the triangle. So this is the thing which makes the difference. This small h dash distance makes the difference of make the difference between 2x and root 2x, which we calculated from this is the hypotenuse equation. So this root 2x is coming from a different figure, and this 2x is of different figure. This 2x is of the figure which has n number of steps, and where n is tending to infinity, but that step is parallel to the either side of triangle. And this root 2x is coming from the different equation where we do not have such constraint, and this is actually a diagonal of the hypotenuse of the right angle triangle. It is actually the hypotenuse of the triangle. Okay, so I hope you are able to understand this, and it's not a very difficult thing to understand. Okay, again I want to add another point, the mistake was in our problem, it's not actually a paradox. It is explainable, and it's basically just a small thing which we thought is intuitive, but it is actually not. Our intuition tells us if we tend n towards infinity, it will become a diagonal, but actually it does not become diagonal. And there's a small thing I want to tell is it. As of now, we have concluded that this perimeter, or whatever we call it, the path length or the perimeter, this perimeter does not tend towards root 2x. It always remains 2x only. It does not tend towards 2x as we tend n equals to infinity, but instead the perimeter does not tend towards the proper right angle triangle. It does not tend such that it makes a right angle triangle, but the area, of course, the area of this this shaded figure tend towards the area of a right angle triangle. Let us see how. So for that, let us form an equation of the area of this figure. As we can see, if we I can divide this figure into multiple rectangles like this. This is one rectangle, this is another, this is another, and this is another. And the sum of all these rectangles will be the sum of the whole figure. Okay, so let us calculate the area of this figure. Let us do it this side. Let us call A as area, and first we'll see the sum of this, we'll see the area of this triangle. We already know that this side is L, and again this side is also L, so let us multiply L with L itself. Now we add the area of this particular rectangle. This side of the rectangle is L, so let's write L, and then multiply with what would be this total distance? It would be L plus L, which is 2L. So multiplied with 2L. Okay, let us write this way. Now let us write the area of the next rectangle. It would, and if you can see the pattern, it is L multiplied by 3L. And we are not writing the area particularly for this particular case n equals to 8, but we are writing the area for the general case. And let us the next would be plus L into 4L, and it will continue it will continue till the last rectangle, and the area of the last rectangle would be this particular distance L multiplied with its length, which is x. So let's multiply this L with x. Now if we simplify this equation, it would be L square plus 2L square plus 3L square till Lx. Now if we take L square as common, it would be 1 plus 2 plus 3 till x by L. Okay, this is simple arithmetic. Now this is the sum of you can see this whole sequence is the sum of natural numbers, and we already know that the sum of natural number equals to n, like where n is the total number of natural number, n into n plus 1 by 2, and in our case n is x by L, because n is the total number of natural numbers. So let us insert the value of n. In our case it's x by L into x by L plus 1 over 2. Okay, so if you simplify this equation, it would turn out to be L into x by 2 into x upon L plus 1. It would turn out to be L into x by 2 into x plus L over L. This L would be cancelled out, and it would turn out to be x by 2 into x plus L. Okay, this would be the final equation of the area of this figure for any given n. And let us also insert the value of L, x upon 2 into x plus, and we know that L is equal to x upon n by 2. It would be 2 into n upon x. Okay, this is the final equation. Okay, so this is for any case, and let's now tend the n. Let us put n equals to infinity. We can write here area of n where n equals to infinity would be equal to limit n tending to infinity x by 2 into x plus 2 into n upon x. Okay, I'm sorry, I did a small mistake in here. Instead of it would be 2 into n upon x, it would be 2 into x over n. Okay, let us correct it here also, 2 into x over n. Okay, so if it let's put n equals to infinity, so it would be a 2x over infinity. So any finite number over infinity would be 0. Okay, so this thing, as you can see, comes out to be equals to x square over 2. Okay, so as you can see, at n equals to infinity, it turns out to be a finite number. Area is a finite number here, and it is not function of n. And in fact, you can confirm that area of right angle triangle, we can write the area of right angle triangle is, as we know, it is half into base into height, where we can put the value of b, and which is base, and h, which is height, as x, and x into x, and it would turn out to be x square by 2, and it is same as this. With this, we can confirm that as n tends to infinity, our area of this figure tends to a actual triangle. But as we have previously previously seen here, that if n tends to infinity, the perimeter does not tend to the perimeter or the length of this hypotenuse in a right angle triangle. So with this, we have concluded our problem. I hope you enjoyed this session, and yeah, that's it. Goodbye.